Hey everyone, welcome to part 6 of my ZZ tutorial. In this video, I'm going to show you guys some last layer things. You get the last layer right after you solve the F2L. So once you're done with that, there are a variety of things you can do, and I'll give you some options just in a few moments. I just want to put it out there that I myself use some of the last layers I'm about to describe. I'll tell you exactly which one I use, and obviously there will be some last layer methods that I don't use, but I think I know enough about it to at least be able to describe it to you if I don't actually use it. So I'm going to give you a variety of options. First, I'll talk to you about the number of cases because that's something everyone wants to know, and then I'll talk about how practical I think it is and just my experience with it. Some of it I will have a lot of experience, and some of it I will have no experience. But for those of the cases with no experience, at least I'll give you a thorough description. So let's get started with the first one. Okay, so let's talk about OLL and PLL. So this is the most basic form of last layer you can pursue, and it's very, very lightweight. Because you get the cross on top here, you only get 7 different OLL cases. They're called OCLL or OLLC. C stands for corners. And once you encounter one of the 7 and do the algorithm, you'll run into a set of 21 PLLs. So 28 algorithms in total, in the grand scheme of things, isn't too bad. And I'll just give you a quick demonstration. So this is one of the OLLs you could get. So people do this algorithm a lot, and this becomes an A perm. So people just do that. So that's a common way to handle the last layer, OLL, PLL. A lot of it overlaps with CFOP already. So if you are familiar with CFOP, you can, just go straight ahead and do the last layer like that, and it'll get the job done. All right, so let's talk a little bit about COLL and EPLL. So COLL is a collection of 42 cases. And what it does is it solves the corners of the last layer. And when I say solve, I mean completely solve. So not only will it solve the orientation, so it'll flip all the corners facing up, but it will permute them as well. So it goes a little bit farther than OLL PLL because OLL just orients them, COLL orients them and permutes them. And because it does more, it has more cases. So let's take a look at this one. This is exactly the same case I had previously, except previously I did something 2gen here and I got an A perm. But if I apply the COLL, I get a Z perm. And the chances of Z perm are actually not as great as the chances of a U perm. You could get mostly U perm, and then Z perm is less likely than U perm, and H perm is less likely than Z perm, and you can also get a PLL skip. The chance of PLL skip is 1 in 12, so that's really nice, and this is a Z perm, like that. So COLL is really, really cool because it really, really simplifies the last step you have to do, and it's really, really nice for one-handed as well because most of the EPLLs, barring some H perms, are very, very comfortable, very, very straightforward, and very, very fast for one-handed. So if you are a fan of one-handed or want to become one, highly suggest learning COLL because it is a very strong alg set to use for one-handed. Now let's talk a little bit about the learning process of COLL. I think the learning process is a little bit smoother than OLL because COLL is entirely based on the 7 OCLL cases, and if you don't know the COLL, you can just straight up do the OCLL and you'll still not waste too much time. I feel like when people learn OLL and they don't know the case, they have to two-look it, and there's just so many looks. So I think in that sense, COLL is a bit smoother to learn. I'm not saying it's superior or anything, but for a person just starting out, it might be a little bit forgiving if you don't know the case. The other thing is you can do something like partial COLL. And what I mean by partial CLL is you don't have to learn all the algorithms. I myself don't use all the algorithms. I don't use the soon and anti-soon cases because I feel that the normal OLL is fast enough and it's not worth the extra moves and the extra look to get some sort of EPLL as long as I can complete the OLL sub 1, which is something I can do quite readily. So I actually don't use anti-soon and soon COLL. I know some people who do, and it's entirely a personal preference. Just for me, I feel like I'm better off not doing it. So if there are any algorithm sets that you don't want to do in COLL, you can simply make it up by just using an OCLL, and you won't lose that much time. So I think that's the cool thing about the learning process of COLL. It's much more forgiving. So that's pretty much COLL in a nutshell. I will have a lot of links in the description to just show you guys where you can find algorithms and text. I have one-handed COLL uploaded on my channel, but for two-handed COLL, I have a lot of interesting links. You can check it out, and it'll direct you to places that have more optimized two-handed COLL. All right, so let's quickly talk about OCELL and CPLL. So this algorithm set isn't particularly widespread as COLL, EPLL, but it has been proposed as an interesting alternative, and I'll just quickly describe to you what it is. I don't use it myself, but OCELL stands for orienting the corners and permuting the edges. So instead of orienting corners and permuting corners, it orients the corners and permutes the edges. So you will have 4 CPLL cases left after doing it, and those are the PLLs that only affect corners. So you can get an H perm, one of the 2 A perms, and the E perm. And if, obviously you can get a skip, but those are the things you can receive afterwards. And generally speaking, for one-handed, EPLL is faster than CPLL, but you know, that's not an entirely adequate reason to just flat out dismiss the method. So I'm just putting it out there that it exists. Again, I will have a link on it in the description if you want to do a little more reading. I don't think that many people use this algorithm set very much, but if you're interested in it, it's out there for you to take a look at. All right, so let's talk about the ZZ variants that are named after letters. We have ZZA, B, C, and D, and all 4 are attempts at making a one-look last layer, and that is great on paper because obviously it's fewer moves and fewer looks, so it's bound to get faster times if you practice it well. Unfortunately, the case count is really high, so that's a huge barrier to entry, and that barrier stops a lot of people from actually trying them, including myself. So let's talk about ZZA first. It's very straightforward. What you do in ZZA is you use ZBLL after solving the F2L. And that is a very hard thing to do because there are 493 cases. Some of them are PLL, but still 493 minus PLL equals still a lot, still in the high 400s. So a lot of people don't use ZA, and I don't think actually anyone uses ZZA fully because it's so difficult to incorporate all the ZBLL cases. ZZB, however, is a different story. What the solver does is, in a nutshell, when they solve the last pair, they affect the edges, and there is either a solved, all edges solved, or parity, which means the edges are not adjacent to each other with respect to each other. So there are only 2 different edge case possibilities instead of all the edges floating around randomly in ZZA. And that really cuts down on the number of cases. For ZZB, there are only 167 last layer cases. And I said only because I was comparing it to ZZA. 167 isn't a walk in the park, but you know, it's a more practical shot at one look last layer. I will have phasing tutorials in the description in case you want to read more about it. There are people that are way more well-versed in phasing than I am because I don't actively use it. So let's talk about ZZC. ZZC isn't really talked about because I guess people don't think it's very practical. What happens in ZZC is when the solver puts the last pair in, they also orient all the corners. And that comes out to be a lot of cases. And I don't know exactly how many because it hasn't been fully documented to my knowledge. But the main idea is you orient the corners while you insert the last pair. Lastly, ZZD, I find is the most interesting because what ZZD does is it permutes all the corners after you solve half of the F2L. So say you solve the EO line in the left block and you have the right block left. So before you start solving the right block, you permute the corners. And according to the documentation, it doesn't require that many more moves, but once you do, the rest of the solve is 2-gen, and that sounds like complete heaven. Unfortunately, there's always some qualifier or bad news, and in this case, recognizing corner permutation is tough. And a lot of variants have been developed in attempt to make corner permutation recognition easier, but they all have their own weaknesses, such as it's just annoying to do, or the steps you have to take are very particular, so it cuts down on your freedom, or just adds more moves than you really are comfortable with. So there exists method variants of this method variant ZZD, and the corner permutation problem is widely known as the quote-unquote missing link, and it's been said that if someone ever comes out with a solution to the missing link, ZZD will be incredible. And once you finish the F2L with ZZD, you can run into an ALK set called 2GLL, which is an ALK set containing 85 cases, and it's basically a subset of ZBLL, but 2-gen. So it's quite nice for one-handed because it's 2-gen, but again, many cases and steep learning curve. So those are the four methods, variants, I would say, of ZZ that are named after letters. They are one-look class layer options, and all of them are really interesting to think about, though I think ZZB and ZZD have the most practicality and have the most future. Of course, that's my personal opinion. I don't know much about ZZC at all, but I do know that some people, including myself, use portions of all of these variants. I just pick and choose, say, which ZBLL sets I want to know and which 2GLLs I want to know. So can't say I know the whole thing, but I know some of the algorithms that belong in each of the variants to kind of make life easier when I run into a tough case. So maybe just learning from everything everywhere is another option. I don't think that method has a name. It's just learn everything. But those are the four methods named after letters. All right, so let's talk about MGLS integration. For those of you that don't know, MGLS is a last slot and last layer option, and it also applies for CFOP, and I think it was actually designed to be an option for CFOP, designed by Mackie and Lucas Guerin. So it is really interesting because it kind of blends the steps together. So what MGLS normally does is it solves an edge while orienting the edges, and then it solves the corner while orienting the corners. Fortunately for ZZ solvers, the edges are already inserted. So what an MGLS application would be for ZZ is you just solve the edge, and if you have the corner just lying anywhere, you can solve the rest of the corner's orientations. And this is a quick example. This is one of the 8 cases where the corner is pointing this way. If the corner is on the top layer, there are many more cases than just 8. So if you are going to learn this, I suggest learning it with the corner in place but twisted wrong. This case looks like this. But yeah, so it's really handy if you accidentally have an edge solved. You can just treat it as a skipped pair, really, because you're doing OLL. So I use a lot of CLS if I see an edge that is accidentally solved. Otherwise, I would most likely not, purposely solve an edge and do CLS because I would much rather prefer COLL EPLL, but it's very, very handy if you have an edge accidentally solved. I don't know anybody that uses full MGLS ZZ integration, but if you are out there, please comment. I think it is a really, really interesting method. At the same time, it's a nice addition if you thought you've a well-developed last layer already, and you're just looking for that extra kick in your solve if you happen to have an edge solved. So that is pretty much MGLS and ZZ integration. Right, so let's quickly talk about ZZ Blah. I think it's a really interesting and clever variant, and so that's why I have its own segment on this video, because I just think it's cool. What ZZ Blah does is interesting because it kind of moves backwards but forwards at the same time, so you feel like you're not doing anything, but all of a sudden it opens you up to something really interesting. So let's get started with it. So what it does is when the solver puts the last pair in, they misorient the corners on purpose. So instead of orienting the corners are misoriented. And after that's done, you get a H case ZBLL possibility and a pi case ZBLL possibility. And those are the only things that could happen because those are the only OCLLs that can occur when you have no corners oriented. So it kind of feels like you're moving backwards when you're misorienting the corners, but at the same time, it restricts you to two ZBLL sets, which is much better than full ZBLL. So I thought that was really inventive. And even if you don't use it, it kind of shows you the creativity and the just fun potential of thinking about ZZ variants. There are so many other ZZ variants, and this is one that is well thought out, and I don't think anyone expected it. So I thought it was really cool, and that's why I wanted to share it. All right, so this segment is titled What I Do, and I'm just going to list to you guys what I do for last layer. If I get a traditional last layer, I will use COLL, and if I get an anti-soon or a soon, I will just simply use OLL and give myself a PLL. I think the recognition for soon and anti-soon COLL aren't worth it because there are many, many ways to do the soon quickly, and I just don't think that the benefit of an EPLL compensates for the time I lose just looking at what case I have. So that's the reason why I don't use it, and a lot of the COLLs are uncomfortable for one-handed for the soon and anti-soon case, and that's another reason I don't use it because I do one-handed so much. As for ZBLL, I use AUG sets for some T cases and U cases. Most of them are used to just compensate for the ugliness of the COLL. Some COLLs are just inherently worse than others in terms of just comfort, so I use ZBLL so that I don't have to do something else after I do something originally uncomfortable. So that was my thinking behind ZBLL, and the other ZBLLs I know are just things that are easy to do. Perhaps they're combinations or slight adjustments of other AUGs I know, so those I just learned for convenience. I usually don't go out of my way to just learn ZBLL because I think it is really hard to incorporate it in your solve because you don't get a particular ZBLL until you solve many, many, many times or just really lucky. So I don't think there's enough opportunity for me to integrate it into my practice, which is why I don't do it. As for MGLS integration, I do all the cases where the corner is in but twisted, and like 90% of the cases where the corner is facing up on the last layer, and none of the cases where the corner is facing to the side. The reason I chose to learn the ones facing up is because typically if you were just to insert it normally, it would require more moves. So I was just thinking to myself, what the heck, why not skip O along at the same time? So that's my justification for doing it. So when I describe what I do for last layer, it's not very unified, and I just tell people that I don't conform to any specific set of algorithms. So, and that's definitely true. I like to learn from kind of everywhere and just, try to develop myself in different areas. I know some people are very concentrated and some people just aren't, and I'm just the one that likes to learn all sorts of cool stuff. and if I see it, I'll just kind of do it. So that's my style. And yeah, it's important once you finalize your F2L and you know you're sticking to ZZ to pick your own style and see. What I would start to do if you're really serious about ZZ is learning COLL. You can choose for yourself whether to learn soon or anti-soon. That's kind of up to you. Personally, I chose to forgo them, but if you feel like they, help you, then go ahead and get those done. And the rest is really up to you, and it really depends on how much time you want to spend practicing and how you want to go about balancing the rest of your activities in speed solving. So you do other events, because I know that a lot of the things that are done in a 3x3 are quite specific. So if you do other events, it's just up to you to, balance your time. And obviously, the methods with more rewards, such as one look last layer, require slightly more investment in time. So it's totally up to you again. Lastly, if you guys have any questions about last layer related things, just feel free to comment and we'll talk about it. If you need any help finding something and I haven't found it for you already, feel free to comment also and we'll help you track whatever you're looking for. So the next video I will have or basically contain my thoughts on using ZZ in other situations. And so look forward to showing you guys that. See you on the next video.